Today I'll talk about, sorry, very sorry. Today I'll take a look into what is the future of urban air mobility. So I'll focus specifically only on the man-carrying eVTOL aircraft. Okay, so my background is designing eVTOL aircraft and also been working on the AAM, UAM field for the last 10 years. Okay, so we all know that today there's a worldwide traffic problem in every city, major city in the world. And so my dream started 2010 was to design an eVTOL aircraft that can help solve the future of transportation. So this is the eVTOL aircraft I designed back in 2010. I call it the Project Zero. So the Project Zero, it was the world's first eVTOL aircraft. So I designed this in 2010. We successfully flown it in 2011, and then we reviewed it at 2013, the Paris Air Show. So since 2013, there are very few eVTOL companies in the world. As you can see, I'm plotting here on the horizontal axis the years, vertical axis the number of eVTOL company or OEM that are working on the eVTOL aircraft. So between 2010 to 2015, there are very few. However, if we look at today, 2022, there are over 400 startups and companies working in the eVTOL field. Majority of these startups, they're all in the preliminary design phase. Very few are in the certification stage, and none of them has received a type certificate from the FAA or EASA. Majority of these 400 startups, they will not make it because either lacking eVTOL aircraft design expertise or lacking funding. But even 10% of these 400 companies make it in the next 10 years, it will still be 40 companies making eVTOL in the next decade. This is my estimate of how much investment funding worldwide has been spent on eVTOL aircraft in the ecosystem. When I say ecosystem, including the eVTOL aircraft, also vertiports, infrastructure, and other facilities to help promote eVTOL. And the vertical axis, the US in terms of billions of dollars. Today, up to 2022, the world has invested about $3 billion already. By 2030, it will go to as much as $20 billion. This chart shows some of the venture capitalists, the VC, and corporate venture that have already invested in eVTOL. These dollars amount are fundings, they're not valuation. So on the left side, you see some of the famous startup company. For example, Joby, they currently have a funding of $1.8 billion US. The investor includes Toyota, Intel, JetBlue, and they went IPO on February 2021. The other company, including Lithium from Germany, currently they have $930 million. Archer from the US at $850 million. Beta Technology, $510 million. So the rest include Eve, Wisk, Vertical Aerospace, Volocopter, EHang, SkyDrive, Overair. And if you notice, Overair is invested by the Korean Hanwha system. Currently, Hanwha has invested $25 million in Overair. So these are the top 12 eVTOL companies in the world. As you can see, there are many investors from different companies around the world. They including companies like Google, Amazon, Federal Express, Boeing, Porsche car maker, and the Mitsui Sumitomo Bank. So they come from all different industries. It is very interesting now. If we take a look at some of these top companies, there are many cross-industry collaboration. For example, Archer from the United States is collaborating with Fiat Chrysler, the car maker, and United Airlines. Boeing is working with Kitty Hawk and Porsche, car company from Germany. Airbus is working with Rolls-Royce, an Audi car company. Joby is working with Toyota and Uber and US Air Force Agility Prime. So I have provided these slides to our event organizer, so you will be able to see these slides later on and study them. Here is the predicted, the eVTOL market size for both people carrying and also cargo. This is done by Morgan Stanley in 2021. So as you can see, they've shown three different lines, the green line, the dark blue line, and the light blue line. These are the different forecasts for how big the ecosystem can be for the AAM. Let's take a look at the dark blue line, which represents the baseline case. In the baseline case, Morgan Stanley predicts by 2040, the market size will be $1 trillion US. If we're more optimistic, the light blue line shows by 2040, it could be almost $5 trillion. If we're more conservative, then the green line shows at 2040, it still will be as large as $500 billion. So it's a very optimistic for the future urban air mobility market. That's why there's so many startups and companies all want to get into AAM. This is a prediction that shows in the future by 2035, where would be the usage of the urban air mobility. 25% will be in Europe and the rest of the world, 30% will be in America, 45% will be in Asia Pacific. So Asia Pacific including Korea, Japan, China, Singapore, and all the Asian countries. So as you can see, Asia Pacific will be the largest user of urban air mobility. In this chart, let's present you the human carrying eVTOL adaptation curve. So back in 2010 and 2020, that was when eVTOL ideas was just started. And that was when I invented the Project Zero eVTOL. So it's a stealth and prototype. There are very few companies working on it. And from 2020 to 2025, this is what we call the proof of concept stage. And also, companies started engaging the regulatory. Regulatory means like FAA and EASA. Stage 3, 2025 to 2030. This is the stage where different countries and cities will start exploring urban air mobility. I believe 12 cities around the world will try UAM between 2025 and 2030. In stage 4, this is what we call initial commercial deployment. And I believe UAM will expand to more cities around the world. It could be as much as 100 cities around the world. And by stage 5, that is 2040 and beyond, this becomes the large-scale deployment of urban air mobility. This is where the prediction of the ecosystem will be $1.5 trillion or more. So let's take a look. So when we talk about 2025, initially this is what a vertiport could look like. It's a very small vertiport. You will have a holding pad or 2 or 3 eVTOL aircraft, and you have 1 takeoff pad. So it's a very small vertiport. But this is by 2025, it's very soon, almost 3 years from that. In Singapore, we'll be building one of these already. And then starting in 2023, 2024, we'll be providing sightseeing service using one of these eVTOL. Here's another example of a small vertiport for a single eVTOL aircraft, where the eVTOL would land on top of the roof, and on the bottom, you can see the charging station, you can also see the office, and this is where the passenger will check in. By 2028, we can probably start seeing some medium-sized rooftop vertiport building on top of buildings, hospital, and shopping mall. So this is what I call a medium size because it can only hold a few eVTOL at a time. People will travel in the future from vertiport to vertiport. And initially, there'll be very few vertiports per city, maybe only 5 or 6 vertiports by 2025 to 2030. However, as we go to beyond the next decade, from 2030 to 2035 to 2040, we may see many more air taxi hubs per city. For example, this is a top view of Los Angeles City. Here we can see about 20 vertiports, all located at different locations in the city. And each vertiport or air taxi hub could be as far as 20 kilometers to 25 or 30 kilometers. And you can catch from one place to the other. And here's an example of what we call a mega vertiport. This could happen maybe by 2035 to 2040. This will allow simultaneously many eVTOL aircraft to come in for landing at different locations on the path and could simultaneously allow eVTOL to simultaneously take off. With a design like this, it could possibly move thousands of passengers every hour. And this is what we call a mega vertiport. Now let me show an example. What could possibly be the cost of riding these eVTOL aircraft in the future? Here is a map of downtown Los Angeles. So let's say we want to travel from Los Angeles International Airport, LAX, all the way to downtown Los Angeles. So these are the highways and the road in Los Angeles. So if we take a taxi, we take the blue highway road, the blue line will show it takes 30 to 80 minutes, depending on traffic. The distance, 16.7 miles, will cost you $65 US. If we are able to fly on an eVTOL, we can fly directly from Los Angeles Airport to downtown Los Angeles. It'll be only 10 miles, take you 8 minutes, and cost you $60. It costs you $60 because initially, by 2028, we could assume company will be charging $6 per passenger per mile. Now, how can eVTOL help reduce the air mobility price? Let's take a look. On the chart here, I'm showing the cost of three different transportation systems: helicopter, urban air mobility, and taxi. Today, there are many cities around the world, like for example, Rio de Janeiro in Brazil and New York, they already use taxi already use helicopter for air taxi. And right now, currently, they're charging the helicopter price at $14 US per passenger per mile. Today, the taxi cost is about $2.50 per passenger per mile. So initially, we can expect the eVTOL aircraft will charge about $6 per passenger per mile. The goal is by 2032, we would like to see if we can reduce that to the same price as a taxi, $2.50. Okay. Why are we able to reduce the price of the eVTOL compared to flying helicopter? Because let's take a look. In 2027, we forecast a typical 5-passenger helicopter, like on the left, will cost US $3.5 million, while a small eVTOL aircraft, it could cost $2.5 million. And by 2032, the price of the eVTOL could drop down to $2 million. Why is there a price dropping? The reason is because helicopter has many parts. They're very expensive to buy, very expensive to operate and maintain. While electric vehicles have much fewer parts. Here's an example electric car. All you have is the motor control, and the battery. While most car with an engine needs about 30,000 parts. An electric vehicle typically only has about 11,000 parts. So we can expect the same level of reduction from 30,000 parts to 11,000 parts. That's a reduction of about 66% when we change from a helicopter to a electric eVTOL aircraft. However, eVTOL aircraft is not going to replace all helicopter. Let's take a look at helicopter versus eVTOL aircraft. On the pro side, the benefit of helicopter is they're proven, reliable, safe, they're certifiable for long endurance, long range, trustworthy, that large payload, as much as 50% of the maximum gross weight can be carrying payload. The negative side, the con side, mechanically complex, more parts, expensive to maintain. Now let's take a look at eVTOL aircraft. The pros are, it may be quieter, fewer parts, lower cost of ownership. They're very cool, they're very hip. It's a game-changing idea. On the con side, they're unproven, cannot auto-rotate if lost power, short endurance, and short range because of battery, and very low payload capability. Usually, it can only carry 15%, that's 15% of the whole aircraft weight as payload. This is my predicted range versus year for eVTOL aircraft. On the vertical axis is the range in kilometer, horizontal axis is the year. Here I have shown the blue line that today, 2020, our technology now already allow us to fly eVTOL for 100 kilometers. And by 2030, we could able to do 200 kilometers or more. And by 2040, we should be able to do at least 500 kilometers or more. Most of the benefit of the improved range comes from the improvement in the battery. Here on the horizontal, I have shown what is the battery's specific energy level. Today, we can reach 180 watt-hour per kilogram. By 2030, we should be able to reach 350 watt-hour per kilogram. By 2040, I predict at least 750 watt-hour per kilogram. And for intra-city, which means traveling within the city, like inside Seoul, or inside Tokyo, or inside Beijing, typically you're under 60 kilometer range. And for intercity, means travel between city and city. As you can see, today, eVTOL are already good enough to allow intercity travel. If you're a little more optimistic, we can expect even higher range due to better eVTOL aircraft design and even better battery. Now, let's take a look. This is a German company, Liliums. Their goal is to fly at 300 kilometers an hour speed with 300 kilometer range. That means they can fly from London, cross the English Channel to France. They may not be quite able to reach Paris, but at least it can cross the English Channel. Here, the same Lilium aircraft, the eVTOL, is designed to also fly you between many different cities in Northern California. For example, from San Francisco to Lake Tahoe for skiing. And in Europe, the same 300 kilometer range allows you to travel between 5 different countries, from Germany, France, Switzerland, Austria, and Italy. You can easily fly from Zurich all the way to Geneva, or from Geneva to Milan. Now let me talk about who will be the key players in urban air mobility ecosystem. I believe there are basically 5 key players. These are the 5. First one, the eVTOL OEM supplier. OEM stands for Original Equipment Manufacturer. They're the company that will design and manufacture eVTOL aircraft. The supplier could be tier 1 or tier 2 supplier. The second group is what I call the lessor, or owners of the eVTOL. Lessor are usually banks or companies that will lease the aircraft. They'll buy the aircraft and lease it out to operator. And the third group is called the operator. Operator are the group that operates and maintain the eVTOL aircraft for revenue. The fourth group are the infrastructure group. Infrastructure group are the one that operate Vertiport, operate a charging facility. They also provide traffic management for eVTOL aircraft. Number 5, the 5th group is what I call the rideshare apps. They are the one that the passenger can go to their smartphone and then reserve this eVTOL aircraft. So initially, these 5 groups, let's see how much money they'll be investing in terms of percentage. Initially, this represents between 2025 and 2030. Initially, all that most of the investment will be invested, as is shown by the red color, by the eVTOL hardware manufacturer and supplier, because they have to invest a lot of money to design and build these aircraft. Initially, the lessor and owner, the green one, they will also invest money to buy the eVTOL aircraft from the manufacturer, and then they'll be leasing to the operator. The operator will be spending the least amount of money because they do not own the money. They will lease from the lessor. And the other 2 groups are the infrastructure. Infrastructure groups have to spend a lot of money to build the vertiport, to build the heliport, to allow these eVTOL to take off and land. So they have to spend the money to build the structures. The rideshare apps, they're the one like the Uber, and they provide the software to allow customer to order taxi and also to order this eVTOL aircraft. So their investment is on developing this app, the software. Now let's see about the revenue side now. The revenue side is the income. The initial revenue from 2025 to 2035. So these are the first 10 years after urban air mobility start. Half of the revenue of the ecosystem will go to the eVTOL manufacturer because they will be the ones selling many of these eVTOL aircraft. The lessor of the bank, they will have very little income because their incomes, they'll be spending a lot of money buying eVTOL aircraft, but their income coming from the operator paying them back. The operator will have a significant amount of income because every time the passenger fly, they pay the operator. Infrastructure will also have a steady income because they will be charging for takeoff fee, landing fee, battery charging, using their vertiport. That's how they recuperate their investment. And the rideshare app people will also have a very steady income because every time a passenger uses the smartphone, the app to reserve, the app service will also charge a fee. Now let's take a look. What is the steady state revenue beyond 2035 and in the future? Once we reach the future, the number of aircraft becomes steady, and the revenue of the eVTOL aircraft manufacturer, they will still get huge income. However, but the majority of income will go to the operator because by 2035 and beyond, there will be many eVTOL aircraft flying around the world. So the operator will make very good revenue. Same as the infrastructure, they'll continue to make revenue. The rideshare will also continue to make revenue. The income for the lessor is very steady because the operator only pays the lessor at a steady monthly leasing fee. Some eVTOL OEMs, for example, like Volocopter and Joby and Lilium, and some of them, they're very ambitious. They want full vertical integration. What does that mean? For example, rather than having the 5 different parties, even though Volocopter is the OEM manufacturing eVTOL aircraft, but they want to get into the right app business. They also want to get into the operation of their own aircraft. They also want to do the management of traffic, and they want to run the flight hub to operate, and they also want to provide drones and the fleet development of new eVTOL. So that's what I call it vertical integration. Another company, OEM, like Bell Helicopter from the US. Bell is now also focusing on developing both manned eVTOL, cargo drone, and operation app. This is my conservative forecast for manned eVTOL demand worldwide for urban air mobility and usage. Today, there's zero eVTOL flying, doing 0 trips per year. Between 2025 to 2030, there could be as much as 1,000 eVTOL aircraft flying around the world, doing 4 million trips per year. Between 2030 to 2040, there could be 20,000 eVTOL doing 100 million trips per year. Beyond 2040, we can expect over 2 million eVTOLs around the world, doing 10 billion trips per year. Now let's estimate how many eVTOL aircraft will be produced in 2030. So what I've shown here on the horizontal axis, the number of aircraft produced, vertical axis, the number of OEM company. So let's assume there are 8 OEM company that has received type certificate by 2030. So 2 OEMs will produce 100 eVTOLs aircraft per year. So here are the 2 OEM. There's 2 OEM, each produce 100. And let's say there are 4 OEM aircraft companies. Each one of these 4 companies will produce 200 eVTOL aircraft per year. Let's say there are 2 OEM companies, each will produce 300 aircraft per year. So in total, we will have 2 times 100, 4 times 200, and 2 times 300, total 1,600 eVTOL aircraft produced per year by 2030. So that's my forecast. And let's take a look, how much is that dollar-wise? Assume there are 1,600 eVTOL aircraft produced per year. Let's assume there's about 2.2 million US dollar per aircraft at today's dollar. That means the annual aircraft sales will be 1,600 times 2.2 million equals $3.52 billion by 2030. Let's compare this to the forecast, the global new civil helicopter sale for 2030, which could be around US $6 to $8 billion annually, not including spares, supports, and training. So this is pretty good. For a new industry, we can provide $3.52 billion per year. Now let's estimate how much eVTOL aircraft could be produced by 2040. So here is my guess. Assume there will be 40 OEM company has received type certificate by 2040. Let's say there are 10 OEM company producing 1,000 eVTOL aircraft per year. So it's 1,000 aircraft, 10 of them. Let's go to 2,000. Let's say there are 20 OEMs producing 2,000 aircraft per year. And there are 3,000, sorry, and there are another 10 OEM produce 3,000 aircraft. So in total, there'll be 80,000 eVTOL aircraft produced per year by 1940. So assume that there are 80,000 eVTOL aircraft produced by year, even though the price of eVTOL has gone down now to $1.6 million because of increased volume. This will still give you an annual aircraft sale of 80,000 eVTOL aircraft times 1.6 million equals $128 billion revenue. If we add the spares and support, this could easily equal to $200 billion. Now, if an eVTOL aircraft hardware, the company is equal to 15% of the total manned air mobility ecosystem. What do I mean by 15%? Let's take a look at the pie chart I have provided before, right? This is a steady state 2035 revenue. The eVTOL hardware represents about 15% of the entire ecosystem. So let's calculate $200 billion divided by 0.15. That means the entire pie will equal to US $1.3 trillion, which is the entire pie. This is very similar to what I've shown before earlier, that by 2040, we could expect $1 trillion for the market. The aircraft price in general, they will keep on reducing as the year goes on because more units will be produced. Here, let me show you. On the blue line, it shows that between 2025 to 2040, we expect the number of eVTOL aircraft produced to continuously increase. At the same time, assuming at 2025, the average eVTOL price will be around 2.7 million US dollar, and it could go somewhere between 2 million to 3.5 million at this range. Let's assume the average 2.7 million. As the volume increases, the price of eVTOL aircraft will continue to drop, which is very beneficial to stimulate the urban air mobility market. One of the biggest contributor is the battery price. The battery price will help reduce the eVTOL cost. Here, I'm showing the horizontally is the year. Vertically axis, the dark blue color represent the cost of the cell. The vertical, the blue bar represent the battery, the finished pack. Let's take a look back in 2010. The battery pack price is about $650 per kilowatt hour. Today, that price has dropped down to 120 US dollar per kilowatt hour for the battery pack. This is currently the price that paid by car company like Audi, Tesla, BMW, Toyota. In the future, we can continue to expect the price to come down. However, aviation battery could easily cost 2 to 3 times more than what we see here for the electric car. The reason is because aviation requires stringent safety and more battery management system check. This is the technology chart. So today, what is the batteries, the lithium battery specific energy, the vertical axis, plotted watts hour per kilogram versus the specific power it can come out. And we have different type of battery compared. Lead acid, nickel metal hydride, lithium iron. Today, the red line represents today's technology, which basically we can have 250 watt hour per kilogram as the specific energy. In the future, by 2030, I predict we will be able to achieve 500 watt hour per kilogram. We'll be able to achieve at least 1,500 or more watt per kilogram specific power. By 2040, the target is we would like to achieve 1,000 watt hour per kilogram and 2,500 watt per kilogram. So if you're going to design an eVTOL aircraft, these are targets. Hopefully, we can achieve the battery for you to use. We may start to see also hydrogen fuel cell aircraft in use by 2030. I don't believe we'll have eVTOL hydrogen aircraft before 2030 because the technology is not mature yet. So for hydrogen to work, they could use the sun or the solar panel or the wind turbine to basically do electrolysis to break down water into hydrogen. And the hydrogen can be used with fuel cell to power electric airplane. There are many companies that already work on hydrogen-powered fuel cell airplane, but it's not been certified yet. I think there's still a few more years to go. Finally, what are the key challenges to eVTOL and urban air mobility? We still need to fine-tune the technologies, create appropriate infrastructure. That means vertiport, regulation, how are we going to control the flying of so many eVTOL aircraft? We need collaboration and partnership between the design, the government, the academic, and supply chain. We need to regulate entire new industry. We need to overcome the public psychological barrier. What does that mean? People may be afraid to get on these small 5-passenger eVTOL aircraft. That is a psychological barrier. Finally, we need to have public acceptance and affordability. Public acceptance is that noise and also visual pollution. Because do we want to see an aircraft flying above our house, above our building all the time? That is what I call visual pollution. Affordability. Can the price be come down cheap enough to compete with car? Then everyone, and not just the rich people, can fly on these eVTOL aircraft. This is my motto. I always say, if it can be dreamed, it can be built. And I believe air mobility is coming. Since I designed the first Project Zero in 2010, I believe that one day we will have urban air mobility. I think the years are coming. By 2025, we should see some company start operating some city with urban air mobility. Thank you very much. If you have more questions or would like to contact me for any discussion, you can reach me at my email address shown here. Thank you, everyone.